Here's the claim. Inside a planet's celestial sphere, the speed of light is capped. But once you're outside, faster than light becomes possible. Sounds bold. Let's run it through myth versus math. Myth: light's limit is a local, earthbound rule. Math: in special relativity, c isn't a house rule. It's the architecture of space-time. Particle accelerators, signals from distant galaxies. The same equations work everywhere we can check. Myth: FTL propulsion is just waiting beyond Earth's perimeter. Math: to push mass past c, energy demand explodes toward infinity. That's not a bureaucratic limit. It's baked into the Lorentz factor. Now, where speculation gets interesting, you could try to move space, not the ship. The Alcubierre idea contracts space in front, expands it behind apparent FTL without breaking local light speed. Cool on paper, but it needs exotic, negative energy we've never produced at scale. Quantum quirks? Tunneling can look instant, but no clean way to send information faster than light. Space itself can expand faster than light over cosmic distances. Objects recede superluminally because the metric stretches. That's not a spaceship punching through C, it's the stage growing under your feet. About quanta physics theory. There's no mainstream framework by that name showing light's limit is planetary. If you want that idea to compete, it needs math that makes risky predictions we can test and win against relativity where it counts. Timing spectra trajectories, precision clocks. So, what would change my mind? A model with explicit equations, falsifiable predictions, reproducible experiments, independent peer review. Think, a spacecraft timekeeping anomaly that current relativity can't fit, repeated across labs. Until then, c stays the cosmic speed limit for stuff and signals. But engineering space-time itself? That's the frontier worth questioning. Carefully, rigorously, and with receipts. Stay curious and bring data.
Can we travel beyond the speed of light? Theoretically, we can. Technologic, we can't. The distinction you've drawn is a central topic in theoretical physics. The gap between mathematical possibility and physical technological reality. While some equations in general relativity allow for solutions that appear to permit faster than light (FTL) motion, these solutions generally rely on conditions that we currently have no way to engineer. The theoretical loophole. The theoretical models that allow for FTL travel do not actually involve moving an object through space faster than light. Instead, they propose manipulating the structure of spacetime itself. Alcubierre drive. This model suggests creating a warp bubble that contracts space in front of a spacecraft and expands it behind. Because the craft is essentially surfing on a wave of space-time, the ship itself remains stationary within its local frame, technically obeying the local speed limit while the bubble moves at an arbitrary velocity. Wormholes, theoretical tunnels, Einstein-Rosen bridges, could connect two distant points in space-time, allowing for a shortcut that bypasses the vast distance between them. The technological and physical barriers. Even though these solutions are mathematically sound in general relativity, they encounter deal-breaker problems when you try to apply them to the real world. The energy requirement. These models often require exotic matter or negative energy density, substances that have not been observed in any meaningful quantity in nature. While the Casimir effect shows that negative energy can exist on a microscopic scale, we have no technology to generate or harness it in the massive quantities needed for propulsion. Stability and causality. Many of these theoretical constructs, like wormholes, are predicted to be incredibly unstable and would likely collapse instantly without a constant, massive energy input. Furthermore, FTL travel is widely believed to violate causality, the principle that cause must precede effect, meaning that FTL could theoretically allow for information to be sent into the past, creating paradoxes that current physical laws are designed to prevent. The infinite energy wall. For any object with mass, standard physics dictates that as you approach the speed of light, your relativistic mass increases toward infinity, requiring infinite energy to accelerate further. There is no known technological pathway to bypass this for physical spacecraft. Summary. In short, theoretically, we can solve equations that describe spacetime manipulation, but these solutions usually require impossible physics like negative mass or infinite energy. Technologically, we are nowhere near the scale required to influence spacetime. We currently struggle to accelerate even tiny subatomic particles to near light speed in the Large Hadron Collider, which consumes vast amounts of energy to do so. As of now, FTL remains a fascinating sandbox for mathematics and science fiction, but it is effectively barred by both our current technological limitations and our fundamental understanding of how the universe maintains causality. Distinction between manipulating space versus moving through space clarify why these theoretical models haven't led to a working engine yet.